Assalamualaikum warahmatullahi wabarakatuh. I am Arifan Munsyadjan from Informatic Program Study. I want to explain what computer organization and architecture. Introduction to computer system. Computer. What is computer? Computer are tools for humans with a working system that receives input in the form of data, process the input, and produce output in the form in information. Basic function of a computer system. Number one, input. Keyboard, mouse, scanner, and other. Output. Monitor or other graphic display. Printer, speaker, and others. Processing data is the function where the computer actually does its job, namely manipulating and controlling data from the entire system. Manipulating here is from raw data to a more informative form or information. Storage, hard drive or external storage device. Compilation system, programming language. What is a programming language? Programming language is a language that is meant for humans to communicate with computers. The unstructured human mind must be structured so that it can communicate with computers. Computers require certainty and correct logic to be able to carry out certain instructions. For this reason, a good and correct algorithm is needed. Machine, machine language. Machine language is a language that contains machine code that can only be interpreted directly by a computer machine. Machine language is often also called native code. It rarely depends on the particular machine. This language is the lowest level language and is in the form of binary code 0 and 1. A collection of instructions in machine language can form microcode, a kind of procedure in machine language. Assembly language. It is a symbolic form of machine language, considered to be the first programming language in the form of string and is easier for humans to understand. Each machine language code has its own symbol in assembly language. High-level language. This language is closer to human language. This language also provides many faculties to make programming easier. For example, variables, data types, constants, control structures, loop, function, procedures, and so on. Hardware organization. Hardware organization. Computer hardware is all the physical computer and is distinguished by the data that is in it or that operates in it, such as motherboard, power supply, processor, RAM, hard disk, CD drives, CMOS battery, video cards, sound cards, etc. Performance issues. Instruction execution rate. A processor is driven by a clock with a constant frequency for equivalency, a constant cycle time. Define the instruction count for a program as the number of machine instructions executed for that program until it runs the completion of or for some defined interval. Note that this is the number of instruction execution, not the number of instructions in the object code of the program. The processor time. The time to transfer depends on the memory cycle time, which may be greater than the processor cycle time. The fifth performance factor in the proceeding execution. 1. The design of the instruction set, now as instruction set architecture. 2. Compiler technology, how effective the compiler is in the producing an efficient machine language program from a high-level language program. 3. Processor implementation. 4. Cache and memory hierarchy. A top-level view of the computer function and interconnection. Computer components. Contemporary computer design are based on concepts developed by John von Neumann at the Institute for Advanced Studies, Princeton, referred to as von Neumann architecture and is based on their key concept. Data and instructions are stored in a single read-with memory. The content of this memory are addressable by location without regard to the type of data contained there. Execution occurs in a sequential fashion, from one instruction to the text. Hardware program, the result of the process of connecting the various components in the CERN configuration. Fetch cycle. At the beginning of each instruction cycle, the processor fetches an instruction from memory. The program counter holds the address of the instruction to be fetched next. The processor increments the PC after each instruction fetch so that it will fetch the next instruction in sequence. The fetched instruction is loaded into the instruction register. The processor interprets the instruction and performs the required action. Interrupt cycle. Added to instruction cycle, process check for interrupt. If no interruption, if interruption pending, suspend execution of the current program. Save content, set PC to start address of interruption handler router. Process interrupt, restore contact, and continue the interrupted program. A top-level view of computer function and interconnection. Data bus. Data lines that provide a path for moving data among system models may consist of or more may consist of 326418 or more paired lines. The number of lines is referred to as the width of the data bus. The number of lines determines how many bits can be transferred at time. The width of the data bus is a key factor in determining overall system performance. Address bus. Used to set the source of destination of the data on the data bus. If the processor wishes to read a word of data from memory, it puts the address of the desired word on the address lines. Width determines the maximum possible memory capacity of the system. Also used to address ports. The higher order bits are used to select a particular module on the bus, and the lower order bits select a memory location on the I/O port in the module. Control bus used to control the access and the use of the data and address lines. Because the data and address lines are served by a concept, there must be a means of controlling their use. Control signal transmit command and timing information among system modules. Timing signal indicate the validity of data and address information. Command signal specificity operation to be performed. The memory hierarchy, location, and performance. Memory. Memory is the part of the computer where program and data are stored. The term store or storage refers to memory. Although the word store is often used to refer to diskette storage, a place for information read and written. Various types, technologies, organization, performance, and process. Memory parameters. There are four important parameters that are considered in choosing a memory: capacity, speed, latency, bandwidth. Bit and byte. Bit, base unit of memory binary digit, consists of the numbers 0 and 1. Bytes, 1 byte equals na bit. 1 kilobyte 1024 bit. Characteristic of memory system. Location. Referred to written memory is internal or external to the computer. Internal memory is often equated with main memory. Process record is our location memory in the form of register. Chats in another form of internal memory. External memory consists of perishable storage devices that are accessible to the process via I/O controls. Capacity. Memory is typically expressed in the terms of bytes. Memory. Memory. The use of their level exploits the fact that semiconductor memory comes in a variety of types with differ in speed and cost. Data are stored more permanently on external mass storage devices. External. Non-volatile memory is also referred to as secondary memory or auxiliary memory. Diskettes. A partition of main memory can be used as a buffer to hold data temporarily that is to be read out to disk. A few large transfer of data can be used instead of many small transfer of data. Data can be retrieved rapidly from the software chats rather than slowly from the disk. Chats, small amount of flash memory. Seatbelt between normal memory and CPU may be located on CPU chip or module. High-speed secondary data storage machines used to store frequently accessed data or instruction. Test providers memory speeds close to the fastest available memory, and at the same time provider large memory capacity at a lower price and than other types semiconductor memory. Why test? Accelerated working memory so that it appreciates processor speed. Main memory is large in capacity but slower to operate, while cache memory is small but faster. Memory cache contains copies of main memory. Cache memory is designed to combine the memory access time of expensive high-speed memory combined with the large memory size of less expensive lower speed memory. Internal memory. RAM or random access memory. Random access device allows store the directly accessible data in random order. RAM technology is divided into two technologies. First, dynamic RAM, DRAM. Second, static RAM, SRAM. Synchronous DRAM. Access is synchronized with an external clock. Address is presented to RAM. RAM feeding data, CPU wait in conventional DRAM. Since CD-RAM moves data in time with the system clock, the CPU knows when data will be ready. CPU does not have to wait in conditioning else. Burst mode allows CD-RAM to set upstream of data and fire it out in block. DDR or CD-RAM send data twice per clock cycle, leading and trailing edge. That's RAM. Mitsubishi integrated smart RAM that's onto generic DRAM chips used on two chips. Mitsubishi integrates smart RAM chips onto generic DRAM chips used as two chips. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.